Okay, so these are the models for our forces labs. So the third law model, we used two force plates, and we got two students to push against one another, or one student act on the other, and the result was a graph that was symmetric about the x-axis, which means that it proves Newton's third law because for every action there's always a reaction of equal force, so that would make it an interaction. The first law is referring to when there is no acceleration, the net force is zero. So we did this by getting a force sensor and hanging masses, and we got the forces acting on the weights, so this would be 50 newtons because 5 kilograms, 3 kilograms is 30 newtons, 1 kilogram is 10 newtons. 10 newtons is similar to the force of gravity being 10 meters per second squared. And also, if we use Newton's second law, net force equals mass times acceleration, net force equals mass times zero. If there's zero acceleration, that means the whole total net force would equal zero, and the only force acting would just be weight. And then second law revolves around the concept of net force equals mass times acceleration. So how we tested this was we got a hanging mass, tied it to a car, and then we got data sets and basically proved that this worked in scenarios that seemed it was appropriate.